So today's going to be a little bit different. I'm going to take a little break from Joust, and I'm going to be making an example or a starting project for a birthday party coming up for a friend of mine. I'm trying to make a spinning wheel, like on a game show, and you'll spin it, and then it'll stop on a genre, and then that's the genre you have to pick for a karaoke song. So that's what I'm going to be doing. I'm going to start building it today. I made a repo on Git for it already with nothing in it, so I'll just clone it right now. And then kind of do the whole process from the start so you guys can see how I start a project from scratch and how hopefully we'll see how far we can get today just in one day of working on it. I'm hoping we'll get some programmer art spinning wheel that we hit spacebar and it'll spin and then it'll slowly stop. That's what I'm hoping by the end of today, but we'll see how far we get. Is that it? Yep. Okay. So we go into our karaoke. Now if we ls, we've got a readme. What we really want to do is start the project with I've got a template for love, which is, we'll walk through it once I put it in there, but we can walk through it and see if it's even working. So if we ls, we've got a couple different things. And if let's first take a look at our main. So we'll open new vim here. Now, I'm gonna put this to our harpoon so we can jump to it. All we're doing is requiring a push library for scaling up the artwork to fit the full screen and everything. We require a state machine and a base state, two classes for and class, which allows class functionality within Lua. We're setting a couple variables for our window width, window height, and setting our filter for our rendering, setting our title for our window, giving us a font we can use, setting the font, having a sounds table. We don't have any sounds at the moment. But then here's our push setup where we can enable full screen. Here is where we'll add our different state machines. So with our state machine class, this is how we have to use it. We basically just have a function that returns the name of the state. And then if we take a look at playstate, which we will in a second, you'll see what that is looking like. Now, the state machine works like this, where we would say global state machine : change, and we can just say change with a string called playstate, and playstate is the return function of our playstate. And then we're fleshing our keyboard.keysPressed. And then here is just, escape is quit. And then we have a function that takes the key. So like love has this loved keyboard key pressed that gets populated. So we're using this was pressed function we just wrote. And if the key was pressed, then we're going to change a table called keys pressed at that index of the key to return true, otherwise false. So that will hopefully allow us to add some, if spacebar is pressed, spin the wheel sort of deal. And then our update in our main function is just running update on our global state machine. we're fleshing our table of keys pressed every frame so we can flesh that out, so we only care about the key that was pressed in that very frame. Then we erase it. Then push render, that's just the dynamic virtual resolution rendering. We render our state machine. We've got a display FPS function, which I'll probably turn off. But we also would need, ideally we would want a, let's take a look at our play state before we get any further. But so in our states, we've got a play state. Yeah, we can get rid of all this actually. This is our template that we don't need anymore. But here is how we tell the state machine that this is a state, essentially. So we have a class library. So this is play state is getting assigned a class instantiation that inherits the base state functionality. So this line turns our playstate.lua into, as far as Lua is concerned, a state that we can use our state machine to change back and forth from. We don't need any of this. We don't need this. We will change all of this. Then we don't need to render anything really. Let's see if we can get a blue screen. So what we want to do is clear the screen to actually 0 on the red, 0 on the green. Let's do 200 on the blue. Full transparency for that 4th argument. So we want to take a look at the rest of our stuff. We just give ourselves a pixel font. Here's those things, like here's the base state. This is all the base state class is doing, is giving us a couple different functions we can use for each state. So every time we instantiate, anytime we make a state, we're saying, hey, it includes base state, so it's kind of like a way of inheriting all of those functions. So we have to do it for every single state. Push for the resizing class. This is to enable that class structure. I don't understand it, but this allows us to use classes in Lua, so that's nice. And then the state machine, which I also don't exactly know. Someone wrote it, and then it's just very simple to use the play state. This is the usage. It's super easy. You just say G state machine gets, and then you give it a string of what state you want it. Let's see if we run. Let's see if, nice, we've got that blue screen. I want, here, let's give us a new TMUX session, actually. I should have quit our old TMUX session. TMUX new session, and it's called karaoke. Okay, let's rename this to play state. CD into our get / karaoke. Karaoke. What is it called? What? Oh. We gotta go here, CD, karaoke. Okay. So now, we run our game. We've got a blue screen. What I actually want is, here, this is our main. I need our play state harpooned. So we'll go here, play state. It's leader A, and we've got play state harpooned, and now we can do our main and our play state, just like that. Thanks, Primogen. So let's say we want this a less bright blue. We can give ourselves a little bit of this color, 12. We can see what that looks like. Yeah, a little less harsh. So, what is the order of operations here? What do we want to do? First of all, I want to give us a new file called notes. So I think it's percent. What is it? Percent. Yeah, percent notes.lua, and we can say that this is just. Actually, we don't even need a Lua file for this. But we want to. We need to make a circle with divided pies for genres. So like make programmer art circle. Okay, and then we need to spin circle. Then we need to space bar to spin circle. And then we need to spin slows to stop. And then we need sound for spin. So we've got a little list. Let's go ahead and put our notes to our harpoon also. So let's make us the circle, and we'll see if we can just get a circle on screen. I use Sprite for the art. So well, let's just do it. I don't have my water. Oh, great. Really? So yeah, we hopefully we can figure out how to just get the circle rotating without spinning its axis point, you know, like the very center needs to be the anchor point, whatever you want to call it, so that when we rotate it doesn't move. You know, the center of gravity doesn't move or whatever. And then we need to spin upon like a click or something. After that, then we need to spin and slow down. Then we can add the sounds. So I don't think it's going to be that hard. But I haven't really messed with drawing circles in Love 2D just yet. Or rotating circles. So that could prove to be difficult. Let's see what Love 2D circles looks like. So we give it a mode in X and Y, a radius, segments. So there's no rotate. There's no rotate. So that's going to be problematic. Well, so the thing is this is how to draw a circle in Love, which we actually aren't doing. What we are doing is going to be exporting a circle from Sprite and then need to rotate that. So let's say Love 2D rotate image. And then we can see. Cool. Let's give us a new file. We'll make it 1,000 by 1,000. We don't want it to grayscale. Let's try that again. Okay. Now, we do want, you know, maybe we want a white circle, a black outline. So if we give ourselves this, we can make this. Where here is the size. I don't use Sprite very often. Can't tell. So there's the size there. So let's say this is like 5 pixels. Nice. Okay. So we just need to make sure this is dead center so that it is not wobbly when we rotate it. It's almost there. It's gotta be a better way than this. Okay, so we got a circle. Now let's give us light, and then we want eyes. So let's give us 5. And we want black. We want the line. Okay. Why doesn't that show up? 5. Okay. Nice. Cool. So something like this. This is just the example. I'll probably go to Photoshop for the real one because I'm just better at Photoshop than Sprite. But we just want a circle that can spin as a proof of concept. Okay, so we've got a pie. Let's just give us different colors actually here. I want to do like a pastel kind of color palette, lighter colors. So we can see it when it spins. Okay, that's bad. Why is that like that? If we go pencil tool and erase, we should be able to erase it easier. Not that any of this actually matters. It's just the perfectionist in me wanting it to look good when we test. B for pencil. Then, so in a couple minutes, we've got a little, programmer art wheel out of a proof of concept that we can test the spin. And if the anchor point is different than the middle, it's going to look wobbly when it spins. So that's why I probably want to do it in Photoshop, because I can set up things better there. but this is 1,000 by 1,000, and we want to save it. In our Get karaoke, and we'll make a new folder here called pics, and we'll save it as wheel1.png. Okay, now we've saved it. We should be able to minimize this, import it. So we should be able to. So this is how you import into Lua, right? You go to your main. You need to give yourself a drawable. So up here, we will give ourselves drawable. We'll call it wheel, and we'll say wheel gets. We'll say wheel gets love.graphics.new image, and the new image takes a string, and that string is a path. That path is pics/wheel1.png. Now our wheel is a drawable, and it's global, so we should be able to go to our play state here and render the background. Then we say love.graphics.draw, and what we want to draw is our real drawable. But then we need to give it an X and Y, so we'll just give it, for now, we'll just give it an X of 30, I don't know. It won't be centered until we do some math, but 30 and 0. So it should be close to the top of the screen and a little shifted over if we did that right. Cool. So how do we get this in the middle? Well, we know I gotta pull out a pen here. It's cool though. We already got, our game is coming together already. Here we go. Oh shit. Okay. Here we go. We've got 1920 wide. So our circle is 1,000 wide. So in order for our 1,000 to be in the middle, what is the middle of 1920? So 1920 divided by 2 is 5,460. 546. Is that right? No, it's not right. Uh, 960. I don't know how I messed that up so bad. Okay. So 960 is the middle point, so we need the middle of our circle to be at 960. So that means 500 pixels in needs to be equal to 960 pixels. So what that means is if we have an X of 0, we are if we have an X of 0, we are 460 pixels off. So we need an X of 460 to be center justified left to right, and then for our Y, we want that to be centered, assuming 1,000 by 1,000 image. We need it's 1,000 by 1,000. 1080 is the height, and we're at 1,000, so 540 needs to be our middle. So if we have a Y of 0, we're 40 pixels off. 40 pixels too high, so our Y needs to be 40, I think. So let's try that. We need an X of 460. and we need a y of 40. Let's see if that's looking more centered. Nice. Cool. How do we rotate this? So we're a square image. Now it looks like the fourth let's see. Rotate, love.graphics rotate. I don't think I want that. Is it a parameter on the drawing? Angle. We update our angle. Where do we? Here, use the fourth argument. Why would math.pi divided by 4 do or something like that? Let's just give it a fourth argument and see what happens. XY, and then we want a rotate. Let's just say 3. Yeah, way off. Okay. So yeah, it's way off. We need it to rotate not the X position, because the X, or like the position origin point is the top left. So if we're rotating around that, it'll kind of spin way off the screen. Maybe we can demo that right now. So let's say our knit has a rotate, and it gets 1. Now in our update, we're gonna update a rotate by itself. And I don't know if 1 is 1 degree or what, but rotate gets rotate plus 5, let's say. And then we're gonna put this at rotate. Oh yeah. Oh yeah. We need to look up how this works. Is it... Let's just try this math.pi divided by 2, they say. Or math.pi dot... That would be a consistent thing, though. I want to be changing. I want to see it rotate. Math.pi divided by 4. Yeah, that's not what I want to do. See, like rotate and then the XS offset of... yeah, well, okay. I think we just need to do this. We need to look up love.graphics.draw, what that looks like. And then figure something out here. Okay, so the fourth argument is orientation in radians. Okay, so that's why. It's in radians, not degrees. How do you convert radians? How do you convert degrees to radians? I don't know. Let's try that. Convert degrees to radians. Multiply the number of degrees by pi over 180 is radians. So how do you... If you want to know what it is in radians, you multiply 90 by pi over 180. You know, like a sane person. To change from radians to degrees, multiply the number of radians. Okay. By pi over. Still don't get it. Degrees. No, yeah, we want degrees to radians. Because ideally we want to just keep track of it in degrees, because that's easy to think of. I don't know how to think of radians, which is an error on my part, I guess. To convert from degrees, you multiply number of degrees by pi over 180. So let us try some fancy stuff. We're gonna what we want to do is give ourselves a variable called rotation. Okay, we're going to start it at 0. We're going to increment our rotation we're going to increment our rotation by 1 every second. But we want it to loop around back to 360, right? So after it gets to 360, back to 0. Okay. First of all, let's just make sure we're printing a rotation that is we want to print rotation, and then we want to concatenate that with a string of our rotation integer. And then we want to print this over on the left side, I guess. So we'll just say string and then x maybe 5, y maybe 5. Rotation at this rate is going to do a full loop maybe every 5 seconds or whatever that was. So if we give our rotation variable, look at what happens if we don't convert. This will just be disappeared after 1 frame. Maybe not. Oh god. Oh god. Okay. So we want actually this to be modulo 360, right? So we want to say, hey, increment this, but then modulo, turn the remainder after you divide it by 360, so that we don't get higher than 360. So anytime it gets up to 360, it's back to 0. Yep. Okay. So that's working. But we need to convert this to radians. So what we want to do is we want to say radians gets whatever our rotation is, but multiplied number of degrees multiplied by pi over 180. So we want to multiply by, and we want to multiply by math.pi over 180, and hopefully then we can say, hey, we're actually going to rotate on the radians. Oh buddy. Yeah, buddy. Yeah, buddy. Okay. Now, this is rotating at the top left corner. Oh, shoot, that's just what I needed. We need to go here. Fifth argument, or fourth argument? No. Fifth argument, I don't know. Radians, then scale factor, x, y, then x offset, y offset. So we need 0, 0, and then 500, 500. Maybe. Because 500 being the halfway point of our 1,000 image. So we need to go here. We're gonna say, okay, radians rotation, 0 on the scale x, 0 on the scale y, 500 on the offset x, 500 on the offset y. And we're gone. Where are we at? Where are we at? We need, not 0, we need 1. And then 500, 500. Okay, come on, spin. Nice, 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 nice. Just wrong. But we spinning. We spinning. Now, why is it that it's so far off? Rotating it. I don't know. I don't know. Let's take a look at another. Oops. Oh God. What did I do? 500, 500. Yeah, the middle is not centered. But we can just eyeball this. Oh, I don't like the look of that. I don't like that we'd have to do that. What if we add 500 to this and add 500 to the other one? We got spinning wheel. We got spinning wheel. Now it looks like we get... Oh, it's looking okay. This is awesome. Cool. Okay. Let's change our rotation to be called degrees. So what we can do is say we want to take out rotation and turn it into degrees. Just like that. And then now we've got degrees, and we can go ahead and print up radians just because I'm curious what radians even equal. So we can say radians. We can print up radians, and we can place it right below. Come on, man. You hate me. Just looking a little laggy there. Okay, I don't think I care about radians. Radians go from 0 to 6. Kind of weird. We're just getting lag, probably because this is running. Cool. So we've got a spinning wheel. Let's see if we speed this up. We speed it up to 5 times as fast. It's looking okay. So we kind of want to find a high end and a low end for how fast we want it to spin. This is probably the fastest we'd want it to spin, but just to see. Oh yeah, that looks good. Okay, so this might be the high end. But do we want to floor our degrees? Do we want to say math.floor, then do our degrees, so that we don't get any weird decimals? The circle actually looks pretty even. The middle is off, but it looks pretty good for being the test one. Okay. So I think flooring it is the move. Even though it looks a little choppier. Moving slow, but... Oh, I think that's fine. So, we want the spin to build up to a fast spin and then slow down to a stop, yeah? So, ideally it'd be kind of cool if you could, like, as long as you hold the space bar, it kind of speeds up, and then when you let go, it slows down to a stop. So maybe we'll do that and then build in a top speed. So let's... What do we want to do? Let's first... We need to give ourselves... Right now... So basically the only way it's rotating is we pass it in the radians. And the radians are calculated by the degrees of which to rotate. So we need to give ourselves a way to modify our degrees based on a button press and then have that value slow down over time. So right now, degrees is just getting set to be degrees plus 1, modded by 360. But we don't want that. We want specifically only to modify degrees if we press a button. So if we don't press a button, degrees is 0. But if we press a button, we need to say, we need to do something like love.keyboard was pressed. And the thing that was pressed is what? Space, bar, or enter. So we can say, oops, or love.keyboard.wasPressed is return. No. Let's just do, no. Never mind. We'll just do space. Space is pressed. Then space is pressed. Then we want to increment our degrees. Actually, yeah, we can say, okay, we want to do not was pressed, but is down. Check for continuous input. So we can say is down, and if space is down, then we increment our degrees. We increment our degrees by a certain amount, like 1 degree a second, or building up. Let's say we say degrees gets. Nope. 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 What are you doing to me, man? All my fault. Degrees gets updated by what do we want? If it's held, let's just do our old logic here. And it'll only happen if space is down. So if we paste it, oh, come on. Okay, ink, paste. Okay. So now we should only spin if we hold spacebar. Nice. So what we want ultimately is kind of spacebar to speed up and speed up and speed up and speed up till it hits a max speed. And then when we let go, not stop completely, but slow down to a stop. So let's first figure out how to slow down to a stop, which I don't know exactly how to do. So what we need is, right now, degrees is only modified if we hold down space. But if we let go of space, we need it to slow down. So it's almost like we need to copy our degrees, because in a sense, our degrees is kind of our speed. No. The rate at which our degrees change is our speed. So we need it to have a speed somehow. So instead of modifying degrees by our current degrees, we need to do that. But if we multiply all of this. Actually, yeah, if we do a degrees plus 1, multiply it by a speed, then we can change speed. Yeah, let's try a sort of velocity. Velocity, right? So like, what if our velocity is 10? Now we need to modify by our current degrees, but multiplied by our velocity. So our velocity actually needs to be kind of small. We'll just give it 2. Actually, we'll give it 5 just to see. So it's like if space is down, oopsie. If space is down, we want velocity to kind of slowly increase up to a max speed, but we're not worrying about that now. We just want to say, hey, modify our degrees by our current degrees, but also by a velocity. So we can say, put in this velocity before we convert it to degrees. Now it should be 5 times as fast when we hold it. And then if we change velocity to be slower, like 1, it should be back to our original. Yep. Okay, so now the secret is we need to modify our velocity. We need to change our velocity based on how long we're held down. So let's just try to speed it up. So if our velocity is held, if space is held down, velocity is going to get modified by a very small number because this is happening every single frame. So it's going to say get current velocity plus let's just do 0.1 to see how fast it is. Did I save it? Yeah, that's way too fast. Let's do 0.01. So 0.01. So if space is held, see how it's sped up? So yeah, it needs to be very small number. Up until a max amount. 0.01. I don't want to get any smaller than that though, so multiplying it by our velocity, but what if we cut our velocity in half so we don't have to... This is silly. I gotta get better at using better parentheses, but we cut our velocity by 5. Not working. God, it goes so fast. And then by the time, okay. We can, fuck. Let's see what 0.01 velocity looks like again. And it doesn't look to be working. Okay. It just goes, it starts slow. I don't want that. Because it's being multiplied by a number. We need to figure this out better. I don't want to do this. So, if we have velocity of 0.001, it just gets so big so fast. Should slowly ramp up, speed up. We need to print up our velocity so we can see what that looks like. Velocity is, and we need to oops, not what I wanted. I want to say velocity, but we actually want to do a math.floor of that velocity, just to make it look easier. Place with 80, I don't know. How come our velocity is 1? Velocity is getting modified if we... Shoot, man. Why is our velocity 1? It's just floored. I guess we don't floor it. See? Yeah, we like our velocity being 1. It's just we need to cut this. What if we don't multiply it by velocity, we just add it by velocity? That'll be a lot slower build-up. And then we can have a reasonable velocity, like a positive number, like 1. Oh, actually, that'll be super fast. How about 0.01? Let's just see what our velocity grows to. Okay. Yeah. So our top velocity we'd want is somewhere around somewhere around 12 maybe. But we want it to get to 12 in 3 seconds or so. So let's say that this is 0.1. That'll be... That looked about 3 seconds. Let's do... Actually, no, we don't want it to kind of build up. We want it to be like you spun a wheel, like... Slow down. So something like 0.1. So yeah, we want it to build up faster than that. We don't want... Yeah, I think that's good. I think that's good. So right now, velocity, we're modifying our degrees by our velocity only if spacebar is down. But if spacebar is not down, we need to slow our velocity down. So if we take a look at our velocity, it builds and builds and builds. We need to cap it. Let's do that first. Let's cap it. We'll cap it at math dot minimum, and we give it velocity, but then we also give it the max velocity, which is 12. And then it should be capped at 12. Nice. We can go maybe to 15. Nice. Now when we let go, we don't want it to stop in one frame. So that's where this comes in place. We need to slow our velocity down to 1 if it's not held down. So we need to say otherwise, velocity will get updated to be itself. And then we want to do basically the opposite of how we speed it up. So it's velocity minus 0.2. So velocity gets itself minus a 0.2. So it should slow down if space is not held. Let's see if that works. But look, yeah. Our velocity is getting negative here. So we need to cap this out. So we'll say math.max value. So we don't want it to be a negative value. So we give it in as a 1. So if it ever goes lower than 1, it's just going to be set to 1. So now velocity is 1. We hold it, we spin, we let go, and it slows down to 1. Now velocity does in fact slow to 1, but we're not slowing our degrees. So we'll actually have to take this and do this also based on velocity. But since our velocity degrees gets... Oh yeah, we don't want to modify our degrees. What is it? That's close. Speeds up, slows down. But we need degrees. What do we do? So our velocity is in fact set right. What if we, hold on, let me just see what velocity 0 starts with, looks like. We cap it. So we need to cap it at 0 now. I am bad at Vim. Okay. Yeah, we'd want velocity to be 0 when it stops, just because that makes sense. So velocity does slow down, but we're not. What happens is our degrees stops getting changed. So whatever our degree is, by the time we let go of space, it just stops. So we need to, oh yeah. We need to not, no, why can't we? What if, hold on, what if we take out the +1 and just have velocity here? Yeah. Okay. So okay. Now our velocity slows down, but that doesn't update our degrees. Right here, we're modifying our degrees by our velocity. And we still need to do that if it's not being held, but our velocity will get smaller and smaller. So this, I'm hoping, will slow us down when we let go. Yes. Yes. So we can build up to 15. That looks pretty good. And letting go should actually decrement slower than the build up. So what we can do is minus a 0.1 instead, and then we can actually cap this out at maybe a bit faster. Maybe we'll try 20 and see what that looks like. So it speeds up to 20. That's looking pretty cool. And then we let go and it slows down. Nice. So we need a little arrow to kind of say, like, hey, this is where the song stops on, dude. Okay. So let's give us this little arrow. Let's go ahead and make it in a sprite. So we can, let me just see what a 10 square looks like on this, or a 20 square on this looks like. Let's see. What does 20 pixels look like? Okay. So if we have a 20 pixel arrow coming to a point, that should look decent. Might be a bit thicker than 20. So let's, what size would we want it? Like we want, you know, we want it to kind of come down. Come on, dude. Why you do this? Just let me select it. Why you do this? Won't let me select things. Let's just say if a quarter of this would be 500 by, or 250 by 250, no, 500 by 500, yeah, then we'd want it maybe 250 by 250. So let's just give ourselves a 250 by 250. We might modify this, yeah, because let's give us a 30 pixel line for the arrow. And that'll be this. Have a red. Have it a line. We need an arrow. This arrow needs to be like a sharp point, though. Okay, so we'll say we just want to shape this a bit. Why? Why? What are you doing? Whatever. A sharp. sharp line here. We don't, why is this not working? Why is the rectangle marked key not working? I should highlight the selection when I do that, no? What am I missing? Set selection, no. What? Okay, there we go. We want this to be perfectly in the middle. Just want a sharp point there. Want a sharp point so that we can tell what it lands on. How do we do? Can we do an erase on this? No. How do we erase like a sharp? I guess if we give ourselves a thick old line like this, we can give ourselves a different color and just erase it. So let's say yeah. So we can give ourselves we can just draw this out better. Okay. Cool. Okay. So we can delete this now. Got a little arrow now. Don't like the shape of the ends here. We can... Why does that look so bad? Looks really bad. Looks really bad. This is just programmer art. We'll make a better arrow later. Let's go ahead and save as arrow1.png. Quit. Nope. We'll just leave it open actually. So we need to go to our main, give us a new drawable. And our new drawable is called Arrow. And it is called Arrow 1. Now let's try to place it. We need to draw it at our place it here. We'll draw it on top of our wheel, not under it. We'll say love.graphics.draw, and we want to draw our arrow drawable. We want to draw it at least. I mean, I guess we can start at, no, I don't know. Let's just do it at this here. 960 by 540, that should be half the screen. No. 960, but then 0 maybe. See if arrow is on. Nice. We need to shift it left. Let's see what 100 looks like. Okay, shift it left more, so we need maybe 850. Okay, we need a little less, so maybe 820. A little less. Okay, a little. Looks pretty damn center. So let's actually shift it up just a bit. Nice. Cool. I want a border for it. So let's get a sprite. And we'll keep the same everything except give it a border, a black border. I want it a brighter red. Easier to see red. And then a black border. It's just the programmer art for it. We will make it look prettier. So we can save this over arrow 1. And then now, when we reload the same exact file, we should get the outline. Nice. This is sick. Cool, dude. That's awesome. That was more than I was hoping to get done today. So if you keep holding it, it maxes out at 19. You let go, it slows down. So we have to come up with the genres, then do the better art, but that's a majority of it. We did it from scratch today, and then we can add, add up the final touches of with the better artwork, better music. I probably won't do that on stream, but I'll do that and then maybe make an episode showing it off. But we got a programmer art version of it. I want to scoot up the arrow just a bit still. Maybe that's a bit too high. Maybe a bit too high still, I don't know. I'll make better artwork for it. You can spin it. And stop it. So cool. So yeah, we'll put different genres here, and then people can come and hold spacebar to spin, let go when they want to let go, and then it'll slow to a stop. Sick, dude. That's sick. That's sick. It's just like Twister. That's sick. That's awesome. Cool. So once I figure out the genres, then it's just a case of adding the genres, making the better artwork, and then potentially adding music. It would be cool to add a clicking noise depending on the velocity. So that will be one of the next steps. Let's take a look at our notes and see what we needed. So programmer art circle. Got it. Spin circle. Got it. Spacebar to spin circle. Got it. Spin slows to a stop. Got it. Sound for spin. Do we want to do that now? Why not? Might as well. Let's just try to do it. By default, Love 2D only allows one sound playing at a given time, where we want to do the same sound before it's over so that it can click rapidly. So in the past I've used TE sound, and it works very easily. I will go ahead and download TE sound and incorporate it and see if we can get it to work. Oh, I've already got it, TE Sound Master. So let's go ahead and actually just look in that. TE Sound. Okay, come on. Great. Where is TE sound? See, am I going crazy? Extract. Where? Documents. Okay, show me those files. Okay, TE sound.lua. So if we look at the README, okay, different. We want to see the usage. Here is TE sound. We'll put this in our karaoke dependencies. We'll put it right here. TE sound. Nope. So all we got to do is require TE sound in our main. In our update, we've got to add the TE sound cleanup. Then all we got to do is do TE sound.play and then the sound, and the sound is a sound data. So we will we need a clicking sound. Let's see if we can download a clicking sound. How do we royalty-free sound effects? Cool. That's pretty good. Ooh, I like that too. Let's just do this. We'll put it in our sounds folder we don't have yet. Okay. So let's actually take a look at the usage again. We need to require TE sound. So in our main.lua, we require dependencies. So we will just require dependencies slash TE sound. As long as that file is in our dependencies, which we should check, TE sound is just lowercase. So TE sound lowercase. So we should be able to say TE sound. And then we TE sound cleanup in our love update. So load update. We will clean up TE sound. So we will say TE sound. Our LSP already picked it up. Cleanup. But like that. Let's see, we don't crash, so that's good. So now we just need to play it the amount of times our velocity is, basically. What does that even mean? If our velocity is 14, we need to play it how many times in a second? Once a second? I don't know. I don't know. I don't know. Let's give us the sound object. So we'll give us in our sounds table, it's click.mp3. So it's sounds/click.mp3. So we will say here where we do our drawables, we will also give ourselves, we got the sounds table right here. We don't need the sounds table though, because we only have one sound, so I'm thinking we just kind of give ourselves we just need a drawable here, or a soundable. Call it click. And it's music/click.mp3. Right? So if we take a look at the usage again, all we got to do to play it is call tesound.play, click. So let's just try to do it. Let's just try to do it here. We'll set, let's set a timer. Let's just call it click, actually. We'll say click gets 0 to start out with. And then anytime, actually we want to say in our update, let's just do a click gets incremented, yeah, by a little number. And then if click is greater than 5, then we want to play the click. Not what I wanted. If click is greater than 5, then we want to tesound.play, and we want to play click. And then after we play click, we want to set click back to 0, so it will then continue to increment so we can play it again. So now let's listen for the click. Okay, music. It's not music, it's sounds. So let's go to our here, go to our music, and it's actually sounds. You must specify a sound. Oh, not a source. Drop path. Oh, you don't need a drawable. You can just give it a string. So let's just do this. Instead of playing click, we play the source. We want this to be faster though. Let's listen for the click. Okay. Streamer static. Okay. So we just need to say static. Okay, come on, click. Okay. Okay. Let us print up. Oh, and click. Okay, click is also, click can't be the variable and the soundable. So we don't need the soundable actually. tesound just does it. But if we go to our debugging, we can, not what I wanted, yank it, paste it, buy it, use it, break it, click, print up our click, and really not what I wanted. Maybe another 150. Yeah, let's do our click every 1 second. So we've got clicking going. Now, if we wanted to see how fast the clicking sound can sound like, we can say if clicking sounds greater than 0.1. Go ahead, play it. Nice. So we've got it working. We just need to change the rate at which we click depending on our velocity. So velocity 0, no click. Velocity 12, click fast. How do we do that? Well, I don't know. We need to play it more often, like the threshold. The threshold for playing the sound needs to get smaller as our velocity increases. So if our click is, I don't know. It's like we need to convert velocity into clicking sound, but like we need what if we call it something like what would we call it? Hey man. Yeah, we need to kind of convert our velocity into, instead of, like we want, just like how if this number here to play click, if this number is, if this number that if click is smaller than, so like what if we had this called just threshold or whatever, sound threshold, click threshold. We'll say click threshold. Okay, and if our click is greater than the threshold, then we go ahead and play it. But we need that click threshold to be modified based on our velocity. So we'll start off at 0. We don't increase click based on this. We base, what do we do? So like, we need to increase click. No, we don't. What do we do? Do we increase? I don't know. Need to go to the bathroom. Okay, what do we need to do? I don't like this click threshold thing. Okay. The faster or the higher number the velocity is, the faster we need to click, which means the lower this number needs to be. So how do we update how soon we click? Click isn't the right word to call that, but it does trigger click, so I guess it's okay. But we do need something like that threshold. Let's just say threshold. If click is greater than the threshold, we need to play click. So as velocity increases, our threshold needs to be tinier. So we should just do this by delta time. What? No. We don't have a threshold here. Yeah, we need threshold to be a smaller number the higher our velocity is. So how do we make threshold a... I feel like I'm dancing around what I gotta do. So what if our threshold is 0? We play all the time. If our threshold is 3, we play every 3 seconds. Okay. So yeah, we need to convert... I think we need to say something like if our velocity is equal to 0, then our threshold gets 1, like an indefinite 1. So if nope. We actually would need to set our click to be equal to 0. That will stop us from sounding it. But then we need to increment our click. Actually, yeah, we could say if velocity is greater than 0, we increment our click. Otherwise, I don't know. If velocity is greater than 0, so if we're actually spinning, that's when we actually modify our click. So click will get itself plus delta time. We're spinning. And then let's just put the threshold back to 1. No sound, but if we're spinning, we'll spin every threshold of 1. And we're resetting our click to 0 every time we pass that threshold. So now all that's left to do is to make our threshold a different value depending on velocity. We need it to be a smaller threshold when our velocity is bigger. So, for example, if our velocity is 1, we'd want our threshold to be something like 13. Velocity is 2, something like 12. Then if our velocity is 13 maxed out, we'd want our threshold to be smaller than 1 second. So we would go click, 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 click. So how do we figure that out? Our threshold needs to get smaller. As our velocity grows. So we would need to do something like, what would we need to do? We would need to set our threshold to something relation of our velocity. We don't want to copy our velocity, we want it to be like an inverse. So maybe we say threshold divided by velocity. That way, threshold would get, let's say our threshold's, or velocity's 2. That would mean, I don't know. Threshold's 1, threshold gets, I divide by 0 here, which is what is killing us. So we can say if our velocity is greater than 0, do this. Then let's see the ratio. Nope. Let's make this a bigger number. No. So if our velocity is greater than 0, 1 divided by our velocity, 2. Yeah, that's not right, because the bigger, I think I've got it backwards. Velocity divided by threshold. So yeah, it's kind of the opposite of that. Kind of the lower the velocity, the faster it was sounding. We need the inverse of this, but it's not. Well, let's see what our threshold is. So our threshold should get smaller, not bigger, the longer we hold it. I don't get it. I mean, what do we, if velocity is the bigger number, we set threshold according to the velocity. Like, if velocity is 1, we need threshold to be 1. Something like that. Like, what if we just kind of do different fields? Like, if velocity is greater than 0, then we check whether or not velocity is greater than 15 would be the top sphere, the top tier. But then we would say else if velocity was bigger than 10, do the next threshold. Then we can say else if velocity greater than 5, do the next threshold, else if velocity is greater than 2, do the next threshold, and then greater than 1. Something like this. We could just kind of manually put in different thresholds for the different values. Something like that, maybe. So if velocity is greater than 15, we need our threshold to be fast. So our threshold would get, we'd play it every 1/5 of a second, we would play it. So let's see if that alone plays it when it's fast. Okay, that's pretty decent. So let's set our threshold to be maybe a 0.5 if we're bigger than that. Let's see what a 0.5 sounds like by putting it here. No, this is backwards. Okay. Yeah, we just need to put the different values. What we think they need to be. Well, what we can do... Well... Yeah, if the slowest one, this would need to be like once a second or something. For the slow one, yeah. No. Okay, so like once a second or something. This would need to be like 0.9, do 0.8, 0.7. Just kind of walk it down. This would actually be like a 0.3, 0.5, 0.7, something like that. Now let's see if we kind of speed up those clicks. Yes! That's close. That's close. I think we actually want this to be more often. So I think we want this to be 0.8. This to be 0.6, 0.4, 0.3. Something like that. Yes. That's awesome. Still think it needs to be a little faster. So this can be 0.6, 0.5, 0.4, 0.3. A little faster. So we want maybe a 0.3, a 0.2, then a 0.05 max speed. Something like that. 0.5 is too much. Yes, that's the shit. I am so happy with that. You know, ideally it only makes the click sound when it passes a black line, but I'm not about to figure that out. That's pretty damn good. Pretty damn good. I am very happy with that. Let's just clean up our code a bit before our commit. Very straightforward. I guess the only thing I want to do is take off our debugging here. That's sick. Cool. I'm very happy with that. Let's check our notes. Yep, sound for spin. That was the last thing we wanted. We got our whole to-do list done on the project for today. The only thing that's left to do is add the genres, make the better, prettier art, potentially add some sounds, potentially add some animation in the background or something to make it pretty. I don't know. We could do whatever we want. But that is a good commit for this project. We take a look at our git diff. We don't have any because we only had an initial commit. So this will be our first initial commit. Well, our second commit past our initial commit. And we'll just say implemented spinning wheel with clicking sound. Nice. What is our git remote? Set to our URL. Let's change our get remote set URL origin to be our SSH. So git at github.com /karaoke.get git push. Booyah. We got a commit, we got a spinning wheel, we've got clicking sounds. That is very awesome. And then we can modify our top velocity if we want. That might be a bit too fast. But I think it's great. I think it's great. I will catch you guys tomorrow. I'll probably be back on Joust tomorrow because the only thing that's left for this project is better art and the genres, which doesn't make for a too compelling stream, but hopefully this was cool for you guys to see a Love 2D project from start to scratch, or from start to prototype 1, you know, from scratch. It was a cool little session, so I'm glad we kind of captured it, and I'll see you guys tomorrow for some more Joust programming, probably. Thanks for watching.